All right, ladies and gentlemen, we're going to take a look at lesson 5.5. We've studied the 5 ways that we have to prove triangles congruent. And so now what we're going to do is use the fact that we know we have congruent triangles, or the fact that we've proven we have congruent triangles, and then to point out that corresponding parts are congruent. All right, so here's what it's going to look like. We're going to start with the diagram. So in the diagram, it says that segments AB and BD bisect each other. We have to know, think about what that means to be bisecting. And then we want to prove that angle A is congruent to angle B. So notice we're not proving that the triangles are congruent, but if I can list one of my statements as the triangles are congruent, then all the angles, all of the sides are congruent to each other. But as always, what we're going to prove is going to end up being our last statement. So how we go through this, mark any congruent segments or angles that are on the diagram. So we know if AB and BD bisect each other, that means this point M is the middle of each of those segments. So AM is congruent to BM, and we know that DM is congruent to CM. The other thing we know, we talked about when angles meet at a side and share a side, that's a reflexive property. We also know that when they meet at the angle here, that we have congruent angles from our vertical angle property. So, because angles A and B are corresponding angles in triangle ADM and triangle BDC, or I'm sorry, not BDC, BMC, BCM, we want to mark those corresponding parts. We can show that triangle ABM is congruent to triangle BCM, and then that would prove that triangle A is congruent, or angle A is congruent to angle B. So, our first statement, like we said, usually comes from our given. So, segment AB and CD bisect each other at M. How do I know that? Because that was given. We then know that MA is congruent to MB. That's the definition of that angle bisector. We then have angle AMD, so A to M to D, this angle right here, is congruent to BMC, and that's our vertical angle theorem. They then tell us that MD is congruent to MC, so they told us that MD is congruent to MC. Well, that was the same reason those congruency marks went up at the same time MA and MB did. So that's going to have the same reason as step number 2. So this is just the definition of a segment bisector. So when we look at this, we have side angle side. So triangle ADM is congruent to triangle BCM because of side angle side. So, because I have congruent triangles, I know corresponding parts are congruent. So I need to go back up to what I wanted to prove. That's going to be my last statement now. Triangle, or angle A is congruent to angle B. All right, now what they're going to do is they're going to give us triangles, and they could have been doing this all along, and they simply didn't. They're giving us what are called overlapping triangles. So this isn't actually 3 triangles, there's 2 triangles that they want us to have. And so what you're going to need to do is to sketch the overlapping triangles separately. What I'll recommend today, because you have a book assignment that follows this lesson, is that you actually put your paper over each triangle and trace them, and so we'll model that in class. So what we want to do is sketch the triangles separately. So they're telling us to move GHJ, or JGH, so JGH, and they say move it to the left. So I'm going to take that angle, move it to the left. I need to follow the names of that. So this is J, G, H, and then I need to mark any congruency. Well, J was marked, and then H down here was marked. It then says move KHG to the right, and then mark any congruencies. So K had 2 congruence marks, and G had a congruence mark. I need to make sure I'm labeling them. All right, so you're not going to be able to move them like that. Your book isn't animated the way the board is, but you can now see what you were supposed to draw out. Now what we need to do is look for a shared side. Well, where were they overlapping? They overlap that here at G and H. They can also share angles. In this case, they don't share any angles. But which side was the same in both triangles? Well, we said that was GH. If they share a side, we need to mark that as congruent. So GH is congruent to GH. It's like that reflexive property that we have. So now what we're going to do is look at our marked diagram. And what can we use? Well, we have two angles and a side. And remember, if I connect my two angles, that side has not been is not what's connecting them. So I have to use angle, angle, and a side outside of them. It's the not-included side. And so we've just proved that those triangles are congruent. So we're going to take a look at that now in our follow-up. We want you guys to practice drawing those so that they do not overlap, and then label the vertices and mark any congruency marks on there. So when we take a look at this, I've got B up here, and that goes down to A. B is going to go to C. I've got to stop at one of our points, and then I'm going to connect A to C. That makes a triangle. I'm then going to start at B again, and this time go to the left. I'm going to go to D. And then D is connecting over to E, and we can see that that makes a set of our triangles. So we want to mark any congruencies that we have there. Well, we don't have any shared sides this time. What we actually have is this shared angle. So we can mark B as being congruent. We're not looking to prove any congruencies here. They just want to give you guys some practice marking up those diagrams and redrawing them. So for this second follow-up, ladies and gentlemen, okay, we're going to do a checking class. So what that means, you need to do math. All right, so let's take a look at example 3, using the overlapping triangles that we have there. So in the diagram, it says CB is congruent to CE. So we know CB is congruent to CE. And we know that angle DEC, so we know DEC, this angle, is congruent to ABC. So we know that this angle is congruent here. We want to prove that AB is congruent to DE. So what triangles do I need to prove are congruent in order to do that? Well, we want to be able to draw those. So I'm going to take my overlapping triangles and draw them. They kind of give us the space below here. So I'm going to start at angle A. Angle A isn't part of any of the overlap. I've got this weird overlap kind of here in the middle that I've got to figure out. So when I look at A is connected to B, and A is connected down all the way to C. And then we connect C to B. I'm going to start at D. D is connected to E. And then D goes all the way down to C. And then I can connect E to C. Put in the congruency marks that we know. We know angle B and angle E here, now that we've drawn separately, we're congruent. And we know that CE was congruent to CB there. Was there anything that they shared? Well, when we look at that, they did share an angle. So it says which angle is the same in both triangles. Well, we have angle C. So we're going to mark that as congruent. Now we still need to go up and figure out what triangles we're going to try and prove are congruent to each other. When I look at my diagrams, I'm going to start on the left there. Triangle A to B to C would be congruent to D to E to C. So we need to go through and look at what we're going to prove. Well, what was given to us? It was given to us that we had angle DEC was congruent to angle ABC. Now, why didn't I start with the segment? I looked down at step number 2. That was also a given, but I can see that it had segment CB in it. So that's not for this problem. They wanted me to name my angle. So now my second reason is given, so I need to give my second given statement. Segment CB is congruent to segment CE. Now, our reflexive property of congruency, guys, this becomes a little bit different than what we were doing earlier. Reflexive would be anything that they share, and this time we're actually sharing angles. So we're going to have to say angle C is congruent to angle C. So that reflexive property is any part that is shared or overlaps, so shared parts or part. When we look at this, when we look at our diagrams, we've got two angles and the included side. So I was able to prove my triangle's congruent using angle, side, angle. And so once my triangles are congruent, now I can go back and say, yes, I've proven my congruent parts. So segment AB is congruent to segment DE. All right, so we're going to take a look at one last one. There's two checkpoints. We're going to do one together here, and then I'm going to call you guys back for small groups to do the other checkpoint. So if we take a look at that, we have KJ is congruent to KL, and angle J is congruent to angle L. What I need to do is I need to make sure I can get these overlapping triangles separate. So I have KL, M, and when I draw, oops, get my selector up there. When I drag this one to the right, I have K, N, and J. So when we take a look at that, we're going to have statements and reasons. This is our statement. This is our reason. We want to start with our given. So I'm going to say KJ is congruent to KL, and that was given. So let's put those congruency marks in. KJ is congruent to KL. My next congruency, or my next given statement, congruency was angle J is congruent to angle L, and that was also given. So I want to put that in. So I have angle J is congruent to angle L. Well, what we need to look for next is the fact that they had something that overlapped. That overlapping is going to be our reflexive property. All right. And so what overlaps? When I look at my two diagrams, what do they have in common? Well, what they share is this K. So they shared an angle. So I'm going to say that angle K is congruent to angle K. Well, when we look at this, I have a side and two angles. So I have to decide is it angle, side, angle, or angle, angle, side. Well, the side is connecting the two angles. So it's angle, side, angle. So I've proven my two triangles congruent. So I have triangle KNJ is congruent to triangle KML. Remember, we have to have corresponding parts listed. So because J and L were congruent, J and L are both listed last. Now that I've proven the triangle is congruent, I can name my corresponding parts. So NJ is congruent to segment ML, and that's the corresponding parts of congruent triangles are congruent. You can abbreviate it that way. All right, we'll take a look at the second checkpoint problem in class.